Hi everyone, this is the Pangrams problem by HackerRank. The link to this problem will be in the description. The problem says a pangram is a string that contains every letter of the alphabet. Given a sentence, determine whether it is a pangram in the English alphabet. Ignore case. Return either pangram or not pangram as appropriate. So the example, we have the string equals the quick brown fox jumps over the lazy dog, and this string contains all letters of the English alphabet, so we return pangram. The constraints for this problem is that the length of the string must be greater than 0, and the length of the string can be less than or equal to 10 to the power of 3. Each character in our string can be a lowercase alphabetic letter, an uppercase alphabetic letter, or a space value. So we see in this example we have an uppercase letter, lowercase letters, and space. An overview of the solution. So step 1, we store every letter of the alphabet, right? In order to check to see if our given string contains every letter of the alphabet, we need to compare it to something. So that's why we're storing every letter of the alphabet. Step 2, we set all characters in the given string to lowercase. We do this because it specifically tells us to ignore case. Step 3, we loop through every character of the string and we record that that character was found. Step 4, if any characters were not found, we return not pangram, otherwise return pangram. So let's walk through this solution. So given this string, let's first store every letter of the alphabet. You might be wondering, why did I store it like this in a circle? Like, why didn't I store it in an array? And why didn't I store it in order? So this circle, it represents a set. And we're using set for the solution instead of an array. And because of the runtime, right? We will have a faster runtime with our solution using a set than we will using an array. And once we code the solution, I will explain how this is faster than using an array. So our step 1, we stored every letter of the alphabet as a set or within a set. Step 2, we're setting all characters in the given string to lowercase. So here are uppercase letters, and we're going to change that to lowercase. And once again, that's because the problem tells us to ignore case. Step 3, loop through every character of the string, record each character that is found. So the first letter is H, and we see that H is in our set. And the way we're recording whether or not it is found is we're going to remove, so we're going to loop through this entire string, and then for each character in this string, we're going to remove it from our set. And then once we've gone through the entire string, if there are any characters remaining in our set, that means it was not found in our string. So the first letter H, so we'll remove H. O, we'll remove O. Then W, we remove W. Space, so it'll check is space in our set, and it's not, so it doesn't do anything. Nothing gets removed, it moves on to the next letter. So V gets removed, E is removed, X is removed, I is removed, N is removed, G is removed, L is removed, Y is removed. Space does not exist in the set, so nothing gets removed. Q gets removed, U gets removed. I has already been removed, so nothing gets removed from the set. C gets removed, K gets removed, space does not exist. D gets removed, A gets removed, F gets removed. T is removed, space does not exist, so nothing happens. Z is removed, E was already removed, so nothing happens. B gets removed, R gets removed, A was already removed, so nothing happens. S is removed, space does not exist, so nothing happens. L was already removed, so nothing happens. Same for E. And lastly, P is removed. One thing you might be thinking is why not just remove the spaces before we loop through the entire string? And the reason is, in order to remove all of the spaces, we have to loop through the entire string, check each character. Is this a space? Is this a space? Is this a space? Is this a space? Oh, it is. Remove it. So we have to loop through the entire string in order to remove all of the spaces, which inevitably we end up looping through the entire string 2 times, once to remove the spaces and then again to check each character to see if each character exists in the alphabet, right? And so it's better to just leave the spaces in there and loop through 1 time and see, is it a character in this alphabet set? So now that we've gone through the entire string, our last step is to see if any characters were not found, right? So we could see that J and M still exist in the set, which means they were not found in this string. So this string is not Pangram. Go ahead and pause this video, try to solve it on your own, and then we will solve it together. Okay, so the first thing we want to do is have a set of characters, right? And this is going to be all our letters of the alphabet. So it's a lot to add each character. In order to add each character, I would have to say alphabet.add A, and then alphabet.add B, and that's a lot of work. So rather than doing all of that, I am going to just write it as an array, and then I'm going to pass that array to our hash set. So what will happen here is when this hash set is created, it'll iterate through all of the letters and add it to our alphabet. So doing this right here is the same thing as me saying alphabet.add A. It's the same thing as me doing it 1 at a time, except I don't have to do it 1 at a time. So now that we have our alphabet, let's go ahead and go through our entire string, each character of the string. Well, sorry, I almost forgot a step. We want our string to be lowercase because the problem tells us to ignore case. Okay, now that it's lowercase, we will loop through each character of the string. So we're going to say while I equals 0, and we're going to iterate through while the index is less than the length of the string. And we're going to add 1 to I for each loop. So let's get the current character of the string, character. Okay, so I'm getting each character of our string. And now I'm going to remove that character from our set. So if the character does not exist in the set, then this method does nothing. It's not going to throw an error. But if it does exist in the set, then it will remove it from the set. So if the character is A, then A gets removed from the set. But if A has already been removed, then it does nothing. All right. After we remove all the characters, our last thing to do is check the size of our set. So we're going to say, is our set empty? If it's empty, we return Pangram. Otherwise, we're going to return not Pangram. One thing I could do to optimize this is to place this if statement inside of our for loop, right? So say we're given a string, and that string is, the length of it is 10 to the power of 3. Well, if the first 26 letters of the string contain the alphabet, then we only have to check for the first 23 letters. We don't have to check for all letters 10 to the power of 23. As soon as all letters of the alphabet have been removed from the set, then we can return Pangram. Otherwise, we're returning not Pangram. So let's copy and paste this into HackerRank. Check out if it's successful or not. Okay, submit code. And everything runs successfully. So take a moment, pause the video, try to solve for the time complexity and space complexity of this problem. So time complexity is asking what's the relationship between our input and how long it takes for this to run. So we see the first thing I did was instantiate letters, and there's 26 letters in the alphabet, right? And this, it's always going to take the same amount of time to run regardless of our input, because regardless of our input, we're doing the same thing each time. Same thing for a hash set. Regardless of input, we're doing the same thing each time. Now, we have to be careful with things like this, because what is this method doing? This method is iterating through the entire string, checking each and every character, and then if it's uppercase, it's converting it to lowercase. So this actually has a runtime of O of n, where n is the size of the array, because it has to loop through each character to make sure that it's lowercase. Next up, we have this for loop, right? And this for loop iterates through the length of the array. So this is going to be O of n, and once again, where n is the size of our array. And what about this method? What's the runtime of our remove? So the way sets work, the implementation is O of 1. So anytime you remove an element from a set, it's a constant operation. It's an O of 1 operation. Same thing with is empty. This is an O of 1 operation. Cool. So now we can add all this together, and we get O of n plus n. And we could ignore the ones, because in big O notation, we always want the greater value. So O of n plus n is O of 2n. And in big O notation, we always drop the constants. So it's going to be, our time complexity will be O of n. Now for our space complexity, we're asking what's the relationship between our inputs and how much memory is being used. So the amount of memory, we are creating a list of letters and a set of letters, but this is always going to be the same, right? We're always going to have 26 letters for our array and our set regardless of what our input is. So these are going to be O of 1 because it does not change based off our input. We end up removing letters here, but we needed it in the beginning. So it doesn't matter that they're being removed. That doesn't change our space complexity. So our space complexity ends up being O of 1. So why am I using this set instead of just this array, right? So let's suppose I did not use the set and I only used the list. Now, every time we come through, we have to remove the character from our list. So we would have to say letters.remove C. The runtime of this method right here is O of n, where n is the size of the letters list or letters array. Right, and so as you can see, this has a better runtime than this. And so that's why I chose to use set instead of list. Now, the size of this letters array is only 26. So when it's actually not going to make that much of a difference. It'll still be really fast, but this is slightly more optimized than this in terms of runtime. So that concludes this video. Thank you guys for watching. If you have any questions or feedback, please let me know in the comments.